Basically, it's due to a kind of coincidence of two independent developments that recently brought up this big wave of applications, of expectations regarding artificial intelligence. On the one hand, we increasingly, progressively get big data almost from everywhere. And on the other hand, we can see a rapid development of computational power. So big data, the accessibility and availability of big data, together with the availability of big computational power, lead to this great step forward regarding artificial intelligence and enable its usage in almost daily life in all applications such as mobile devices. At Hasso-Plattner Institute, we do research now for more than 10 years in artificial intelligence. Initially, our motivation was to ask, how can artificial intelligence help us in computer vision? For example, for the so-called style transfer. That is, you learn a network, you train a network to get aware of the styles, graphics styles in paintings, and then you can copy these styles for your own digital photography. At this point, we ask ourselves, how can we apply this technology for geodata? It's a kind of digital imagery. Sometimes it's more specialized, but of course, it's obvious that there seem to be many similarities, and this is what we are interested in. We transfer findings from computer vision to the world of geodata. The applications of artificial intelligence are manifold. I cannot even see any field that would not be able to take advantage of artificial intelligence. So we will see it in almost all fields of geodata processing. For example, one core strength of artificial intelligence refers to its ability to interpret unsharp, fuzzy geodata. This is typically a nightmare for all geoinformation systems and processes. However, using artificial intelligence, it can somehow heal bad data to become better data. And this is only one example of the manifold applications. Other applications include analytics, especially predictive analytics in the field of geoinformation systems, and geospatial analysis. Artificial requires big geospatial data, and our current solutions, for example, standard geospatial databases, are hardly able to handle that amount of data. So the question will be, what are more flexible schemes? For example, a combination of in-memory databases together with external memory algorithms. And we also have to think of changing our paradigm, not storing geodata in a single place, not even in the cloud, but dealing and handling and processing geodata streams that most likely will never end, that are constantly delivering us new data. And so the paradigms used to develop algorithms have to be remodeled, have to be reshaped, because otherwise they will not be able to cope with such amounts of data that are required for applying artificial intelligence. In, for example, smart cities, we will basically be confronted with a diverse, heterogeneous number of geodata streams. For example, sensor data, that deliver data about its environment, about the position or the velocity of vehicles. You can imagine many other kinds of sensor data. These streams need to be unified, need to be brought on a single platform, and most likely this will be as a cloud. Yeah, so geodata tends to be absorbed by specialized clouds, and these specialized clouds still have to be developed. There's a number of research topics that first have to be solved unless we can use this way of geodata processing. That will be the future way of handling, storing, managing geodata. Once again, we have to be aware that our current schemas having geodata bases, specialized databases with a large amount of memory, that this model will not work in the future anymore. Yes, of course, there will be a number of revolutionary changes. For example, in the future, most processes will directly not only capture geodata, but also at the same time process geodata and allow us to derive what we are really interested in. Imagine a drone that captures some environment and directly extracts some specific objects, for example, street signs. So there will not anymore a need for a detailed process that defines different stages. Instead, we will be able to directly interpret geodata, and this will accelerate most processes, and this will allow us to create completely new applications. Think of cameras that are used for surveillance purposes and that get trained to detect only some exceptional objects or are sensitive for exceptional behavior. So most geodata will not be used, not be stored, because we are able to take out what really is of interest. So this will allow us to find completely new ways to store geodata, and even more, to store only relevant insights that can be derived from geodata using artificial intelligence. Artificial intelligence offers completely new ways to define processes for the construction arena. For example, if we use 3D point clouds together with artificial intelligence, we can automatically update building information models. We can, for example, create even interior models on a daily basis, taking into account and evaluating this 3D data captured inside a building. We can think of having detection software that is focused on and is trained for specific devices, for specific phenomena that are of interest of an application. So for the building information model world, artificial intelligence will definitely improve the way data can be brought into these processes. For traffic management, artificial intelligence will enable us to build new predictive systems that are able to detect almost in real time upcoming patterns that are of interest and that drive the steering of our traffic flows. Together with on-demand or real-time sensor data, artificial intelligence will a key component for future traffic control systems that are on one hand centralized and control, for example, the infrastructure of the traffic system of a city, but on the other hand can be also built into our devices, into our vehicles, into our cars, and both together can cooperate in a smart way and hopefully lead to a number of improvements in our traffic. In Europe, we have an excellent foundation in the mathematical theory for artificial intelligence. due to our engineering culture and our engineering tradition, we most likely will be able to rapidly embed artificial technology in products. Of course, there's a worldwide competition in that field, and we have to be aware of competitors, and we have to be aware of the rapid progress that takes artificial research, artificial intelligence research. Artificial intelligence and deep learning contain a number of intrinsic risks. Of course, artificial intelligence will enable applications that can touch privacy issues. In that case, our governments, our society, everyone is asked to find ways that allow the application of this technology on the one hand, but also preserve privacy and lead to solutions that are acceptable for our society. This is an ongoing topic, and it's not easy to find good solutions that form and build a compromise between technology, application of technology, and, for example, privacy. Another issue that can be observed is a general overestimation of the capabilities of artificial intelligence. Artificial intelligence will not create, at least not in the foreseeable future, kind of consciousness regarding, for example, spatial environments. This is a very long way to go, but most likely in the next decades it will not be reachable. So sometimes fears are overestimated by histories, by science fiction, and this should be always taken into account when talking about artificial intelligence. And of course, there's another risk in general for artificial intelligence related fields, kind of over-engineering. We can create devices that create awareness of their environment, but most likely for many purposes they will be over-engineered. That is, they apply technology, but at the end they do not deliver a real benefit. And this will be corrected by the market in the long run. In the long run we will see which kind of application of artificial intelligence really brings benefits to the society, to all of us, and which products and systems do not bring benefits. So in the long run, I can foresee a process that will filter the positive developments of artificial intelligence and will filter also the negative developments of artificial intelligence. Geodata is key to these techniques because it's almost the most perfect category of data that can be processed by artificial intelligence algorithms and deep learning algorithms. Because geodata is characterized by a kind of unsharpness and fuzziness. And this is where artificial intelligence can bring us real benefits. So geodata are somehow excellent inputs for all these technologies. And for that reason, artificial intelligence and deep learning will have a great impact on the geoinformatics world, because here we have the right data to be processed by artificial intelligence and deep learning.